Hello, good afternoon everyone. How are you all doing today? Having a good time so far? Yes, so now I can see you, yeah. Okay, all right, I'm Caio Avanzini. I am with Hitachi Astemo here today to present a little bit about what we do for shock absorbers tuning and how we are going virtually towards that direction, focusing on innovation, technology, and the most important part of it, sustainability. So first of all, I would like to give a quick introduction on who we are and what we do. Hitachi Astemo was born back in 2021, January, and it was born after the merge of 4 different companies: Hitachi Automotive Systems, Keihin, Nissin, and Showa. And together, we are stronger. And together, we are Hitachi Astemo. And we are one Hitachi. What do we do? Basically, we do powertrain systems, chassis, motorcycles, ADAS. And for those who are curious about it, what's the meaning of Astemo? It stands for Advanced Sustainable Technologies for Mobility. Okay, let's move on and start talking about this integration. Where do we want to get? We want to be able to integrate everything virtually. Dampers, steering systems, brakes, dynamics behind those components. Be able to integrate them virtually. Make them work together towards performance, delivering the best quality product to our customers. But let's focus now more on the shock absorbers itself, the dampers. The main focus here is we see that we have some issues with long wait time for prototypes. And there is also a crescent demand for quicker quotation responses. Our customers, every time they want to be more quickly, they want us to deliver results in a time that I would say it's even shorter from going onwards. And also, we would love to have the possibility to explore new technologies and evaluate the best solutions to our clients and input all of the technologies that we have. And we can use the virtual environment for that. And we saw that opportunity. We would like to go for the shock absorbers virtual tuning. How to make that happen virtually in the computer. Not only that, we want to increase the efficiency and precision during the tuning phases. We want to be able to reduce the number of take-aparts and prototypes needed in that process. And we at Hitachi, we saw, okay, we have the capability and technology to make this happen now. With that in mind, we said, okay, we need to reshape what we do, the process that we do, how we are doing this since the early steps from the RFQ and the study request from the customer, and how we can manage to take it virtually. So we are using car real time on our side. We're able to tune that, plus the design of the shock absorber itself, the dampers, all the structural information that you guys have. So we'll be able to design that alongside with car real time. And in this process, we want to make it interactive. We want to make sure that we are tuning all of the valve codes, all of the demands, 6, 7, 8 scenarios, virtually. And not only that, we also want to put the Hitachi Astemo technologies inside of those virtual models. And we are able to deliver to the customers not only the response, not only one quotation response or like, a study that you guys have been requesting us. We want to be able to deliver suggestions, work together. So we are able to deliver a quality product and make sure that we have this in an efficient method and are able to work towards the innovation of the virtual process itself. But we don't need to talk all about the whole process as it is. We need to always remember about sustainability and how efficient it is. Since we have an improved response time, those quotations are studies that might take weeks. We are able to make it happen now in a matter of days using the virtual environment. We no longer need to have a lot of prototypes during all the RFQs or development phases and all of the testing. We can make it happen using car real time. And it is sustainable, guys. As a good reminder, some of our customers, they order more than 100 prototypes sometimes in each corner of the car. So this is, we can reduce that number by far just by going virtually in some stages where we have the initial process of it. And the reduction of travel, and this is all linked to the reduction of the carbon footprint. No more, like I say, we need to travel by plane, so we're consuming fuel, the whole logistics behind it's not that simple, you know. So once we are going virtually, this is no longer necessary. So we can make it happen now. Now let's go to the results itself. What are we doing so far and how are we doing this? So we're going all the way from pickup trucks to off-road vehicles. So here's some scenarios from car real-time. And we have the 1D damper model. So Hitachi is able now to develop a huge library with 1D models with all the past technologies, current ones, and the upcoming ones. Frequency reactive dampers, hydraulic stops. Everything's going to be there in our system. And we're able to simulate that and integrate with the car model. And we are having consistent results so far. Here in this example, we have some curves here for the frequency reactive dampers. As you can see, the aggressive behavior right here for the force placement curves and also for the force velocity. We are able to manage that virtually. And those models that we are doing right now, we can work together with the customer and make those tunes specifically for what their needs. And not only about the models itself, but also how we are comparing that to the real-life situations. Here I have some comparison between the virtual model and real-life measurements for a pickup truck. We're able to have consistent data that aligns with the real-life measurements for all the technologies that we are putting into the Simscape. So here's some curves of acceleration. We have a matching curve there. Yaw rate, side sleep, vertical acceleration, body displacement, PSD curves. We are able to look at that and say, okay, we have let's say we are confident that those models are correlating and that we are able to talk with our customers and say, we can do this virtually. Okay. Well, let's go back to the tuning itself. What we can do to improve this process. We have our models from Hitachi. We can add the driver in the loop. So when our customer is driving and feeling this car, feeling this damper, he might want to, okay, we want to make changes here and there. Those attributes here and there, they're not the way that I was expecting them to be. They will send that back to us. And we will be able to change those models in real time and deliver to them exactly what they were expecting. Not only that, we can also put the hardware in the loop, so the damper performance test systems, sending back those signals of displacement, velocity, and we are able to work together and improve this. And as a reminder, the hardware in the loop here, this is at a later stage, right, when we actually need the prototypes itself, so we can feel it for durability and also have a better feeling on how the components will behave in the system as well. So there's quite a few opportunities here that we see, and the best part of it is actually that it doesn't matter actually where the customer is. It can be in Japan, Australia, South Africa, Europe. And we can make this tuning happen remotely. All that they need to do is to have the driver simulator close to them, and we're able to tune remotely for them. So this gives us a lot of possibilities. We can make sure that we are delivering and designing per the demands of the driver, which is a very important, let's say, feature to consider when we are designing the dampers itself. Now I'd like to talk about something completely new, I would say. We've been working on quite a few technologies, but what I'm about to present right now is something that I would say will change the way that we design dampers. For the first time, we'll be using deep learning and machine learning on our side. We at Hitachi, we're collecting all of the test data that we have. We want to make sure that every data that is available, we can add that into a neural network. All of the inputs that we know that the customer might be looking for. Tune those layers for all the vehicle attributes and responses that we expect from a damper. And be able to deliver a product designed with artificial intelligence. We no longer need to go crazy about all the design parameters, everything that might be going wrong into the process. If we can teach this machine how to behave the way that the driver expects it to do. So we're no longer tuning just for the component. We're tuning for the way that the driver will use the vehicle. So this is a way of characterize, I would say, all of the vehicle responses and attributes for the end customer itself. And working together, we were able to correlate those curves with the artificial intelligence model really well with the simulation. And this is connected with car real time because we need those models to work with us. And those systems are all integrated using Simulink. And we were able to test here in this case, as you can see, the blue curves right there, it's the artificial intelligence model. And the red one is just a simulation without it. And one thing that we all saw there is that the efficiency of those models, it's in another level. With those models, actually the previous models, we were able to do simulations that would take sometimes 7, 8, 9 hours. And with the artificial intelligence, we can make it happen in a matter of seconds. So we're designing something brand new, and we're able to make it happen really efficient. And of course, the customer will be happy. Moving on here, guys, it's not only about dampers, okay, that we are looking for those solutions with deep learning and artificial intelligence. We want to integrate other systems in there. Powertrain, brakes, everything around the chassis. We want to design that with artificial intelligence, be able to connect that and use car real time to help us with that. Semi-active dampers. Hitachi right now is focused on developing and priming those semi-active dampers to work with the battery electric vehicles and design them with the artificial intelligence to have the best performance in the market. Test data for all of the components. Excuse me. We want to make sure that everything is integrated in our models with the machine learning. Not only that, this will be fully integrated vehicle that will communicate together using AI. And you are able to build the whole product to the customer in a time record, as we have never seen before. And everything here is built with artificial intelligence. Thank you. My name is Caio. I would like also to thank the team here, Marcus, Murillo, and also Claudio. And thank you again.